Okay, well, I'd like to first of all welcome everyone to today's Open Group webinar. Today's subject is about a universal data element framework and the reduced cost and time producing system interoperability. Before we start, I'd just like to welcome you all here and just cover a few housekeeping issues. We would encourage you all to ask questions, which we would like to field at the end of the event. If you'd like to use the QA facility, the text facility on the right-hand side, that's usually the best way of submitting your questions, and we'll work through them at the end of the event. I'd now like to introduce you to today's speaker. Ron Schultz is a senior partner of UDEF IT LLC. He has over 20 years' experience with national and international data standards covering the gamut from electronic data interchange to the National Information Exchange model. Importantly, he is also the chairman of the Open Growth UDEF project.
Thank you very much, Simon. With that, I will also like to say I greatly appreciate the opportunity that the Open Group has offered for making this presentation. And one of you have asked the question if they're the only participant, and the answer to that question is no. There are several currently participating. So, as Simon indicated, we will use the QA facility on the right-hand side for taking questions, but we'll attempt to leave about 5 minutes or so at the end to address those questions. This is part one of a two-part series. I highly recommend that if you want to understand part two, that you either listen to it live today or within a day or two, you should be able to view it online, the entire 1 hour webinar, and to do so before planning to attend part two, which will be 1 week from today, the 22nd, beginning at the same time. As noted by the title, I want to emphasize that the Universal Data Element Framework is an enabler for reducing the costs and time for achieving systems interoperability. And it is not a complete answer, but it is, I believe, and many others believe, a stepping stone toward that answer. And hopefully by the end of today's session, at least that aspect will be fairly well understood. Also, let me skip on over then to the agenda. The first 6 bullets on this slide are the topics that we will cover in today's session. The remaining 4 topics are the topics that will be addressed in session 2. And that, again, will be a week from today. And we will address what is the problem that the UDEF solves, and fundamentally it's the need for interoperability and too many standards, and then why UDEF is not a data standard. Many think of, well, there's some standard out there, and if I've got that standard, why do I need UDEF? Hopefully by the end of today's session you'll understand why UDEF is different and why it's a critical part of the solution. And then we'll get into the subject of metadata and why metadata is important, and if you want to leverage UDEF, it should be an integral part of a metadata approach within an architecture of a given enterprise. Then spend a fair amount of time on describing the UDEF itself so that you have an appreciation of what it is. And then the UDEF itself, there are 6 basic steps that one follows when applying UDEF to the complete analysis of your data in your enterprise. And then if you've done all that, you'll say, well, now what? Well, there's a free online gap analysis tool provided by the Open Group, and that online gap analysis tool is a key component of why you can reduce costs in integrating any two systems that have been mapped to the UDEF. So we'll briefly describe that in today's session. I'll address the 4 remaining topics more heavily next week. However, I do want to point out that there are some key principles for how you select the best property and how you select the best object when analyzing your data and mapping it to the UDEF, and then show some example mappings as well as some use cases. Okay, let's, without any further ado, let's move forward. From a global perspective, this slide illustrates the fact that no matter what organization you are, at most you can control your own semantics or vocabulary, if you will, and there are organizations that you interact with electronically that you do not control, and they, in essence, have their own vocabulary and, in essence, in some cases will dictate to you, in other cases you might be able to dictate to them, but I'd suggest to you that in no case can one organization dictate to everyone else unless you happen to be a government organization, and even then you can't dictate to other governments. So bottom line is there's a lack of a controlled vocabulary across organizations. And then when you look within your enterprise and you're trying to integrate your various systems, if that large ellipse represents all of the data that's managed by all of your legacy applications, you've got overlaps amongst your applications unless you're a really small enterprise, in which case maybe you can get by with one application. But most enterprises have multiple applications, and there's substantial overlaps and gaps. And then you might say, well, let's everybody use XML. Well, if you do use XML, then you have to be very careful about what you name those entities or those data elements, and you have to also then be careful about the case sensitivity of XML. The illustration there for part number illustrates the fact that even though they're obviously trying to be the same thing, case sensitivity within XML says those are 4 different data elements. So then when you try to integrate all your applications, there's a group of tasks that you normally have to address. You have to analyze and document your business requirements. Then you're, in a design time sense, you're analyzing what in one system is equal to what in another system. Where are the gaps, and are there different forms of representation for that data? And then last but not least, then you do the data transforms at runtime. If the diagram on the right of this page was developed by some chief information officers within the aerospace industry, and at least within that industry, the cost of a single interface can range from anywhere from $10,000 to $1 million, depending on the scope and complexity of the interface. And so you end up with an n times n minus 1, or many will roughly equate that to an n squared problem, and you ultimately then end up with lots of cost, complexity, and time when you're trying to integrate a bunch of different systems. And so that, in essence, is the problem, as well as interfacing systems. And then when you look within your given standards, you have different standards that have conflicting names, terminology, as well as your various applications, which may or may not conform to a given standard. And this simply illustrates a real example of 2 different standards, 2 different applications, all within the same enterprise using different terminology. And so for a given row there's obviously differences in terminology that's used. So if you look at the big picture of standards, there are many, many standards out there. And these are simply the organizations that govern standards. And I won't even try to say that that's a complete list because it absolutely is not. But it illustrates part of the problem. And then when you're trying to deal with a single topic, such as supply chain, then you have, even within the supply chain domain, you have a large number of standards. And so when you're trying to integrate using standards, but when you go across various industries, they don't all conform to the same standard. And so you end up the fact that within a given industry, you may still have to go cross industry when you're trying to use the supply chain. And so you end up with a substantial cost impact shown by the n-squared curve there on the right, simply for the fact that you don't have common terminology. And so I made a statement earlier that UDEF is not a data standard, and hopefully when we're done today, you'll understand why this chart is valid. But in data standards, they typically have to limit themselves to a specific domain. And so data standards are typically domain specific, whereas UDEF is not. In fact, the U of UDEF is universal, and then data standards are typically based on a single data model, whereas UDEF is not. And some might say, well, why isn't it? And hopefully when we're done, you'll appreciate that as well. The primary focus of a data standard is to say, here's a neutral meaning and a neutral representation for a given domain, and everybody mapped to that neutral meaning, neutral representation, and everything is good. UDEF, on the other hand, isn't addressing a neutral, but rather it's saying what's the meaning and behavior of the data within your enterprise applications. And so when you're analyzing your data, you're trying to say, what is the meaning of this the way I'm using it in my application versus how someone else is using it in their application, and if in fact, even though they're using different terminology, if it in fact has the same meaning and behavior, you will end up with the same UDEF name for that. And so there's a different focus between a data standard and the UDEF. Important point here. Also, many, not all, but many data standards do not use a data element naming approach. UDEF, on the other hand, does conform to an international standard on how its data elements are named, which is in conformance with an ISO IEC 11179-5. Again, I'll provide more details later in this presentation. Also, identification approach. Many data standards, if they do assign unique identifiers, they are typically randomly assigned. So the first one might be a 1, second one a 2, or whatever. Whereas with the UDEF, there is a structured identifier, which the identifier itself can be mapped to the UDEF, and the identifier itself conveys meaning. Okay, so these are the fundamental differences between data standards and UDEF. So the goal is that rather than having an n-squared or n times n-1 approach, which shows that cost curve on the left-hand side, you'd like to be able to say that there's an approach that can substantially reduce your costs, your design time costs, and the savings is basically the difference between an n-squared curve and a 2n curve, which is illustrated between the left-hand side and the right-hand side. The open group is the host of the UDEF standard, and it is a standard. the open group has a vision, which is boundaryless information flow. The open group, isn't saying that there aren't boundaries, but that those boundaries are permeable. And that basically then it's saying that you want boundaries, permeable boundaries, not only within the enterprise, but also between enterprises and between nations. So that implies a language aspect. Also, the reason you want boundaryless information flow is you improve productivity, you improve agility. And the bottom line is that traditional IT architectures hinder that vision. So what to do? Well, the open group has its major standard is known as the TOGAF, and the TOGAF is the abbreviation for the Open Group's Architecture Framework. The Open Group's vision statement is shown here, and basically it's boundaryless information flow that enables access to integrated information both within and among enterprises that's based on open standards and global interoperability. And the UDEF is an open standard, and it does enable global interoperability if it's properly applied. So what is interoperability? Within the Open Group's TOGAF, there is a TOGAF version 9, and in it, it has a paragraph 3.48, and the definition of interoperability is as shown here. But basically, it's the ability of two or more systems or components to exchange and use information. In other words, definition 2 is what I'm citing here at the moment. So if you look at interoperability, there really are layers. There's a medium layer, and that's the, if you will, the media that basically allows you, if it's physical, it's plugging a wire into the wall. If it's through the wire or through airwaves, then it's the RF link. But bottom line is you've got a medium that you need to have that the protocols for the medium. And then above that, you've got a technical layer or syntactic layer, and that then provides the ability to deal with syntax and data formats and currency units and so forth. And then above that, you've got a semantic layer. To achieve the semantic layer, you need context-specific metadata. And here's where ontologies and taxonomies and master data come into the picture. And then, last but not least, you have the process layer. So that's where, between the two entities that are trying to exchange the information, they have to be on the same page for the process as well. Okay, so semantic interoperability is there are many ways to interpret that. This is one way to define semantic interoperability. Basically, the shared meaning of a string of characters and or symbols in some language within a context that assures the correct interpretation by all actors. And it also, the semantic interoperability layer has layers of standards. At the syntax layer, you need to agree on a syntax, and that's where XML and XML schema come into the picture. And then for semantic foundation standards, there's the ISO IEC 11179, as well as ISO 15000-5, and I'll describe both of those a little more later. And then there's the domain-specific implementation conventions. This is where you have various data standards that are out there that have, if you will, the payload data standards. And these are just a few of the examples, but ontologies actually fit into this because ontologies have a tendency to be somewhat limited to domains. And then last but not least, you need something that can transcend domains, and that's where multi-domains need alignment, and both UDEF and RDF play important roles in that. I will hopefully be able to answer questions on that with the slides that follow. One more important definition, and this happens to be taken from Wikipedia, and it's dated as of yesterday, is controlled vocabularies. And so controlled vocabularies are a way to organize knowledge so that it can be subsequently retrieved. And it's a way of rather than having no limits on how things are named, but having a control of vocabulary by using mandated, predefined, authorized terms that are pre-selected by the designer of the vocabulary. And that's where the UDEF is fitting into that role. And I'll again provide more details here shortly. Within the Open Groups Architecture Framework, or TOGAF, version 9, they have a bunch of different principles. One of them is Principle 11, and the topic is data principles, data is shared. Obviously, you want to be able to share data within your enterprise and across enterprise functions so that you are able to perform your duties. And you want to do that so that you minimize the impact of the islands of data that exists within the enterprise. That implies the need for either standard data models or data elements, but also metadata. And so metadata becomes a key aspect of being able to share data across the enterprise. So what is metadata? The two boxes, one is data. If I say 1, 2, 3, 4, that's data, and it might exist in some database somewhere. But until I know what the meaning of that data is, which is the metadata, namely it's an invoice number, now all of a sudden it has meaning. And similarly, the number 10, which can have lots of different meanings, but in the case as it relates to an invoice, it means that I ordered 10 of something, and so forth. So metadata is critical for managing data across your enterprise. And what you want to do is establish standard names for that metadata that goes even beyond data standards, unless within your enterprise you can get by with that one data standard and never have to go across other data standards. And so you want to standardize on the names that you assign to data. So that, if you do that, that's also, by the way, a critical enabler of service-oriented architecture or cloud computing. If you want to improve data reuse and data mining, you need standardized metadata. And if you want to improve worker productivity, you need standardized metadata. Okay, so in the big picture of things, you've got data, you've got information, you've got knowledge and wisdom. And to go from data to information, the data has to be put into context using metadata. And then information is that which is still storable on a machine, or it could be something in a person's head. But ultimately, in order for it to be of any value, you want it to become knowledge, in other words, understood, and then ultimately so that decision makers can make better decisions. And so this is a chart frequently seen, a pyramid chart similar to this. And the focus of what I'm going to talk about on the next slide then is the data and the information. If you are familiar with the OSI 7-layer reference model, that 7-layer model basically is used to help communicate ideas about different layers to achieve interoperability. This particular reference model is illustrating the fact that for data, you have both structured data and unstructured data, and then in order for it to be usable as a data management layer, you need a layer of metadata, which in one case could be a data model, or in a case of unstructured, something like file labels, which then gives you the data management layer, and so database management systems, middleware, and so forth, and data standards come into that layer. However, in order for that to become useful information, there's a layer of information or information metadata management, and that's where a naming convention and indexing methods, registry, ontologies, taxonomies, vocabularies become important at that layer, and then ultimately to get to the information management layer. The key here is that the layer that is the information metadata management layer is frequently overlooked, and that's the layer that I'm going to talk about here as what UDEF helps satisfy. But before I do that, I want to briefly mention that ISO IEC 11179 is an international standard, and the UDEF conforms to Part 5 of that 6-part standard. Part 5 deals with naming and identification principles, and the complete all 6 parts are available at that link shown there at the bottom. And so if you go to that standard and download Part 1, it has a brief summary, and these are extracted verbatim from that. Part 1 has a brief summary of what Part 5 covers, and so these 3 bullets are directly out of that Part 1. So it basically provides guidance for naming and identification of data constructs as administered within a metadata registry, and that you should have a naming convention, and that they should have both semantic, syntactic, and lexical rules to form the naming convention. And last but not least, that you should have identifiers that are used for dereferencing the data within your metadata registry. If you look at, again, 11179 and some of the key terminology, they define all of these bubbles that are shown here on this chart. In other words, object, class, property, representation, and the idea of a data element concept. What I want to highlight here is that a data element concept is the union between an object class and a property to give you a data element concept. When you add representation, that's when you get to a data element. And an example of a object class and property combined would be employee hired date. The object is employee, hired date is the property, and date is the representation. I mean, date can be represented many, many different ways. But the concept of employee hired date is a concept that simply requires an object and a property, and that's the key for control vocabulary. How it's represented is also important, but not for understanding the meaning. And so when you add representation, in other words, using the ISO standard for date representation, in other words, 4 numbers for year followed by 2 numbers for month followed by 2 numbers for day, that's one form of representation, but there are many forms. And so all of these are defined within the 11179. However, the data element concept is the key because that's what UDEF addresses. Okay, so what is a metadata managed architecture? Basically, the UDEF itself, and by the way, that vertical bar, the red bar represents, say, your firewall. Everything on the left is within an enterprise, Everything on the right is out there, on the internet. Out there on the internet is the global UDEF registry managed by the Open Group. Anybody with a web browser can view the entire UDEF today. It's out there available for anybody with a browser to look at. Anybody with an email address can be involved directly in contributing to the extension process to the UDEF itself. And all you need to do is self-subscribe for free. Oops, I'm sorry. I bumped the button here. Self-subscribe for free, and you can participate directly in the UDEF extension process and add proposed extensions to the UDEF. If everybody adopted the UDEF, then the UDEF has an ID, which is a structured ID, which then, if it was used within metadata registries across the globe, it would enable discovery of that type of data wherever it resided if it was visible to the public. So, for instance, employee hire date, if that was a concept that you wanted to share with someone, then that you could expose it through the UDEF ID, and that would provide a universal indexing mechanism for discovery of that type of data. And what we're looking for then is for software vendors to include UDEF IDs within their APIs. So the various major application vendors would use UDEF. And then obviously vendors that have canonical models should apply UDEF IDs there as well. Within your enterprise, the need for a metadata registry, basically the metadata registry then gives you the mechanism for discovering where within your own systems you are currently using a given data element concept, and many larger enterprises have the same data residing in multiple locations. And so using this mapping matrices would allow interface developers and application developers within your enterprise to know where to find existing data within your enterprise. UDEF does not deal with representation, and so you still need to deal with transformations, and that's a runtime function, and UDEF does not deal with representation at this time. Okay, let me move on. So there are some relevant open standards. XML is great for structuring, storing, and transporting information. It's a widely recognized, widely used standard. However, the XML tag names are not predefined, so you must define the meaning of all your XML tag names. And RDF, which is a W3C standard, Resource Description Framework, it can be represented in XML. And similar to data modeling, it helps you describe relationships between data or subjects and objects, which are resources within a given domain. The UDEF, on the other hand, is an open standard that helps you establish a common vocabulary that goes across domains. And again, I'll hopefully illustrate how that works here shortly. It does also then give you a language-independent identifier. So whether you speak Dutch or French or English or German or Chinese or whatever, the independent identifier is language independent and allows you to go multi-languages. And by the way, UDEF itself is represented in XML and RDF and can be downloaded from the Open Group's website, both in XML and RDF formats. So a thumbnail sketch of the UDEF is that it's the only truly open standard that will simplify building an enterprise-wide control vocabulary and for structured data that also facilitates normalization across data models. I emphasize across data models. And it enables service-oriented architecture, input-output interoperability across all services that adopt UDEF through the global indexing keys. An individual from Oracle named Daniel Serrain attended one of my in-depth 3-hour tutorials on UDEF, and then subsequently wrote a technical paper on use of UDEF as the indexing key for all SOA services. And the diagram that you see there in the box, but on the right-hand side of the box, is one that comes directly from that paper. The diagram on the left illustrates the fact that the UDEF itself, you can take any number of systems, independently map the names of your concepts in those systems to the UDEF, and then by going through the process that you'll understand more readily after next week's session, then you'll be able to come up with hopefully, not always, but hopefully more often than not, a common mapping between those systems to the UDEF name, which then gives you a common UDEF ID. That UDEF ID then becomes the indexing mechanism across systems, across languages for those same concepts. So let's get into the UDEF itself. I indicated it conforms to 11179-5, and in the center here of this diagram, you'll see the naming convention itself. It says that you should have an object class term with 0 or more qualifiers and a property term with 0 or more qualifiers, and both lists should be controlled lists. The list of property terms shown on the right, amount, for instance, is always monetary. That list comes directly from United Nations UN CFACT, which then became ISO standard 15000-5. Basically says that list then is an international standard, and amount is always monetary, for instance, and it's universal to any application. So hopefully any system out there should be able to map uniquely into one of those properties shown on that list once you understand the meaning of those properties that are on that list. And then you add qualifiers as needed that show up within the UDEF itself. For instance, amount could be price amount or cost amount or tax amount or budget amount and so forth. And that then gives you the qualifiers plus that UDEF property. The list on the left is the object class list, and that's universally applicable to any enterprise. Basically, you can take a given property and then associate it with an object that's relevant to the enterprise, and then when you combine the two, whatever object plus property plus the necessary qualifiers, and then do so using the UDEF approach, you end up with a grammatically correct expression, and for instance, employee, person, family, name. That's a concept that is in the UDEF, and when you string those words together, you end up with a concept then that hopefully anybody in the enterprise will understand, or even with another enterprise. And so you end up then with some grammatically correct expressions that conform to a finite set of objects and a finite set of properties that are then further qualified with qualifiers. Okay. So when you take those 17 objects and then create a taxonomy of them, you end up then with the entire UDEF is nothing more than a bunch of taxonomies. So person and roles of person, so employee person, patient person, and there's a huge number roles for person that show up in the UDEF object trees, but then the property trees do similarly. And so you end up then with a unique identifier based on that tree structure. So a patient person, for instance, patient person family name is a concept that medical offices, hospitals, and doctors' offices and so forth probably all use. And now they share a common UDEF ID, which is derived from the tree structure. You basically walk up the tree structure to the root. So patient is a qualifier of person. So AU.5 is the object side. And on the other side, on the property side, it's 11.10. So AU.5 underscore 11.10 is the unique identifier for that concept that's language independent, application independent, and that then becomes the ID that transcends all systems, all languages. So if you apply that approach then and say, how can I use it within my enterprise? Well, if you currently use relational database systems, basically the object term, in this case employee person, on this page here, that then becomes the identifier. In other words, the A.5 would be the identifier for identifying any table in your enterprise that contains employee data. And then the columns in those tables would be uniquely identified by, in this case, hired date is the underscore 49.6. So A.5 underscore 49.6 is the UDEF ID that transcends all applications and transcends all languages that deals with employee person hired date. So if you go through this process and map your data to the UDEF, and this simply being a few examples for an HR system, so you end up then with these types of UDEF names as the foundation of your control vocabulary that then becomes global, at least for English. But then when you want to transcend languages, you go to the UDEF ID. But that UDEF ID now is something that computers can act on. And then if you go to an HR example, and I want to suggest to you that going through the detailed training and going through the 6 steps that we end up going through in face-to-face meetings, I walk through these steps and support a foundation understanding of understanding how one goes about mapping concepts that they might have in their systems, such as based on a data model. And the box in the upper left is trying to represent the entities and attributes. In other words, employee being an entity, and attributes such as number and hire date and last name and so forth being concepts that you might find in a data model within a given application. So those entity attribute pairs are what you're mapping to the UDEF. And let me go to the next. These then are the 6 basic steps. Again, I'll highlight this again in greater detail in the next session, which will be a week from today. But basically, you follow 6 basic steps when going through the process of analyzing your data and figuring out how to map your data to the UDEF. 6 basic steps. So if you want to leverage the UDEF and realize some cost savings, the way to do that is to leverage the gap analysis tool. And there are 2 examples out there on Open Group's website, and it's opengroup.org/UDEF. In other words, www.opengroup.org/UDEF. And on that page, you will see a place, a topic area called gap analysis. And at that gap analysis, there will be 2 files that you can save to your hard drive. And basically, these are extracts from those 2 files, illustrating whether it could be 2 systems or 2 standards or a system and a standard. It doesn't matter. but you end up then putting UDEF IDs into your XML files, and these being two different standards that both dealing with purchase orders, and then mapping the entire document to the entire purchase order to the UDEF and assigning UDEF IDs as shown here. And so side by side, you've got a source file and a target file, and then you send them to this link here, which is the online gap analysis tool, which is also on that section within the Open Group site. And then you end up with a source system and a target system, both on your same computer, that have UDEF IDs embedded within it. And the result you'll get back within less than a second is what's illustrated here. It shows a column of UDEF IDs, which is what it uses when it does the analysis, and then it shows, what name, tag name equates to the other system's tag name or other standards tag name. And where there's nulls, it says that that concept didn't exist in the other one, which means that potentially because of behavior, in other words, it wasn't represented the same or something, or maybe it just doesn't exist in the other one. That allows you then to focus on those things that need to be addressed in an integration process. And so if independently you've mapped two different systems to the UDEF, use this gap analysis, now you can focus then on the areas that need to be focused, which is where you have a null between the two systems. And so if you take an enhanced view of that gap analysis and then simply add UDEF definitions, it becomes much easier to recognize that what the meaning of these terms are between the two systems if you have the entire UDEF name included as well. And so I show that. Okay, so the need for distributed UDEF. Now, the Open Group online UDEF has a whole lot of concepts in it. However, it is not complete, and so I encourage those of you who want to contribute to do so by self-subscribing for free to participate in the UDEF interested parties. But also, the Open Group lacks, expertise in certain domains. One of them being medical. Now, while there's some expertise, but definitely not what would be necessary in order to fully address that topic. And so, also, the Open Group needs to be vendor neutral. So anything that would be proprietary will not show up in the public UDEF. Some enterprises might end up wanting to extend UDEF differently than another enterprise, and that's fine. So we came up with the concept of a distributed UDEF so that where appropriate, industry extensions could deal with proprietary extensions, or within an enterprise if you wanted to use it totally within your enterprise, or some languages. Some languages have concepts that don't exist in other languages, and so forth. So the concept is to extend the UDEF with concepts that the public UDEF can't handle. And to do that then, there's the public UDEF, which is that global UDEF, and then industry-specific or private extensions. And so at a given node, then there would be descendant trees that deal with those topics that you want to take just to the industry or to within your enterprise. And so that's a concept that's being developed within the Open Group. And again, if anyone's interested in participating in that topic more, we welcome those participants. Some example industry mappings, say the airline industry, showing, for instance, and I'm going to highlight this very top line, the B737-300. That obviously is proprietary to a Boeing aircraft or an A320, such as the fourth line. And so everything to the right of the UDEF ID where it says UDEF-S, everything to the right, for instance, the B.0.1 _ 2.11, that's in the public UDEF, but the A and then .UDEF-S, the A is unique to the aircraft industry in this example. And by the way, aircraft industry hasn't, or airline industry hasn't necessarily adopted this, but I'm illustrating what could be done. And so the A is unique then to that industry. And the UDEF-S is the marker that says you need to go to a different registry to find what the A means. So that's the concept. I want to simply highlight the fact that the UDEF property words all come from come from 15,000-5, which is based on a United Nations standard for UNCFAC, and these property words come directly from that standard, were not invented by the Open Group or the UDEF project team. Whereas the UDEF objects apply context to the properties. So any of those properties could be mapped to any of the objects if it makes sense. But the objects are based on the concept that UDEF is enterprise-centric, and so if you know what enterprise you are, then all of these objects will make sense. So a given enterprise has a product, has one or more products. They have one or more processes. They are governed by laws and rules. They have persons that support the process, or persons that are relevant to the process. There are assets, there are liabilities, there are documents. Where two or more enterprises have some shared objectives, you have something called a program. And then you also have things such as place and event and conditions and substances and plants and animals and environments and entity. Entity has a unique definition within the UDEF. Basically, you use the word entity if it could be two or more of the other objects. And the best example is always the concept of party within the supply chain. A party could be an enterprise or a person. Anyway, these are then the UDEF object words. The key point here is that UDEF is enterprise-centric, and then you get the UDEF level, root level object and property IDs. Each of the objects have their unique, have an identifier, and each of the properties have an identifier. And I will stay with my word and try to provide 5 minutes or so for any questions. Again, for those of you who want a better understanding of the next, how do you map your data to the UDEF, then I encourage you to participate in next week's, a week from today, session. With that, I'll say, Simon, do you want to suggest some questions that I might want to answer?
Ron, many thanks. Excellent presentation. I'll just reiterate, this is a part one of a two-part series, so I'd encourage you all to join us again this time next week for the second part of Ron's presentation. Yeah, Ron, we've got a couple of questions coming via text. The first one from Dave Hay says, can UDEF vocabulary be accessed by OWL? That's O-W-L.
That's a good question. Simple way to answer the question is once someone has self-subscribed to the UDEF interested parties, they will be able to download the entire UDEF in RDF format. And I know that doesn't directly address your question regarding OWL, because that would imply the need for an automated direct interface to the entire UDEF as it currently exists. And and that's something that we are working on. If you send me an email, I'll copy the email onto Chris Harding, who is the Open Group owner and director that supports everything that we're doing with UDEF. He's a staff person, and we'll see what the possibilities might be there, because Chris is very familiar with RDF, OWL, and ontologies.
Thanks, Rob. The other question we have is from Alok Shah, and he's asking, are there any tools available for UDEF integration?
There are tool vendors out there that support the UDEF. Obviously, the one that's freely available to the public is already on the Open Group's website, the gap analysis tool. There are tools available for, I'll just say, supporting the mapping of your data to the UDEF, importing XML files, and then allowing you to do the mapping with the UDEF embedded or already captured within the tool itself. So then you push a button and it automatically gives you your UDEF ID and assigns then to that particular mapping. And then there's also a vendor out there that has UDEF embedded that can support XML schema. And again, I would suggest if someone is interested in that they send me an email, and it's shown here on this business card.
Okay, Ron, well, I think those are the two questions we had. I look at the time, and it's getting close to the top of the hour, so that will be the hour. So I would suggest that this would be a good time to end this session. As I said, once again, reiterate, we hope you can join us for the second part of this. And at that note, I will end this session. Thank you very much, and we look forward to seeing you next week. Many thanks.
Well, one quick item, Simon, before you leave.
Yes, please, Ron, go ahead.
Yeah, one quick item. The full recording will be available tomorrow, and you do have a link there to all participants. So feel free to share that link with others who may not have been able to, whatever reason, weren't able to join us today. It's freely, publicly available.
Yep, that's correct.
Okay, thank you.
All right, many thanks, everybody.
Thanks.